Hello guys, welcome to learning microcontrollers. In this video, I'm going to show you how you can make a LPG and CNG gas detection system. This is a very useful protective system, especially in places like kitchen, where there is a possibility of gas leakage, because once the gas is spread in the room, a little flame can set the whole home on fire. And it has great application in the winter season as well. When we mostly use heaters and other stuff, there might be a leakage of gas. So this small and cheap circuit will help you to tackle such a threat. So we will be using a 16x2 LCD for the purpose of calibration, also to display the output. And along this, I'm going to use an LED which will turn on whenever the gas is detected, and whenever the gas is not detected, it will remain off. So guys, let's get started with this gas detection system. So guys, this is our gas detection sensor. It's a MQ2 sensor. It's very easily available in the market. It can detect the LPG and CNG gas. As you can see, if you hold it like this, it has 4 pins. One on the left side is the VCC, then we have ground, then we have digital output, and then we have analog output pin. Now this digital output pin is the one which will either give 1 or 0 to your microcontroller, while this analog output pin will give an ADC value, which is very good. You can set like whenever minimum gas is detected or more gas is detected, you will have values from 0 to 1023, which you can program as your wish. The more gas is detected, the more the value will increase, while this digital output can only give you either 1 or 0, and you can set the threshold using the potentiometer at the back. So we will not be using digital output, we will only be using analog output pin in this project. So let's get started. So guys, this is our PIC16F877A microcontroller having 40 pins. It's a DIP version. This is our MQ2 gas sensor, as you can see. Now let me show you how to connect it with a PIC. If you hold it like this, the left one is the VCC, then we have ground pin, then digital output, then we have analog output pin. Now you will connect the VCC pin directly with the VCC pin of your PIC microcontroller like this, and the ground pin will go to the ground pin of your PIC microcontroller like this. Leave the digital output pin as it is, then go for the analog output pin. For the analog output pin, you can use any available ADC pin of your PIC. I'm going to use a pin number A0 like this, and then guys, to display the output and also to calibrate the sensor, we will use the 16x2 LCD. This is easily available in the market, and this one has a flashlight. There is also one available which don't have a flashlight. Now to adjust the contrast of this LCD, you will need a 10 kilo ohm resistor, a variable resistor. You can use this type of variable resistor. It is very accurate and easily available everywhere. As you can see that on the body of this potentiometer, you can see the labeling 1, 2 and 3. So these are the pin labeling 1, 2 and 3 like this. Now guys, this LCD has 16 pins. If you hold it like this from left to right, it's 1 to 16. Now guys, let's do the connections. Pin number 1 and 5 of the LCD, you common them, and then you send them to the pin number 1 of the potentiometer, then you send it to the common ground. In this way, your LCD gets grounded and your potentiometer also gets the ground. Now guys, pin number 3 of your LCD is the adjustable contrast pin. You connect it to the adjustable pin of your potentiometer. In this potentiometer, that is pin number 2. So pin number 3 of the LCD will go to the pin number 2 of your potentiometer. Now guys, the VDD pin, that is the pin number 2 of the LCD, will go to the pin number 3 of the potentiometer. Then you send it to the common VCC supply, that is the 5 volt pin of the PIC. In this way, your LCD gets the 5 volt and your potentiometer gets the 5 volt. Now guys, pin number 4 of your LCD is the RS pin. For that, you can use any available digital input output pin of your PIC microcontroller. I'm going to use pin number 15 of the PIC, that is C0. Now for the enable pin, that is the pin number 6 of the LCD, still you can use any digital input output pin. I'm going to use the pin number 16 of the PIC, that is pin number C1. For the data pin 4 of the LCD, that is the pin number 11, I'm going to use the pin number C2 of the PIC. And for the data pin 5 of the LCD, that is pin number 12, I'm going to use the pin number D2 of the PIC. And for the data pin 6 of the LCD, that is the pin number 13, I'm going to use the pin number 22 of the PIC, that is D3. Now for the data pin 7 of the LCD, I'm going to use the pin number C4 of the PIC16F877A. In this way, our LCD is wired up. Now guys, the pin number 15 and 16 of the LCD, they are up for the backlight. If your LCD has a backlight, only then you will connect these 2 pins, else you will not connect these 2 pins at all. So pin number 15 will go to the VCC pin of the PIC. You will give 5 volt to the backlight LED through this pin, and then pin number 16 is a ground pin like this. Now guys, these 4 pins, pin number 7, 8, 9 and 10, they are for the 8-bit mode, while we are using this LCD in the 4-bit mode, so we do not need them. Now guys, the one thing left is the LED now. This is the LED. As you know, LED has 2 pins, one shorter and one longer. The shorter pin is the ground pin, directly send it to the ground. For the longer pin, you will need a 220 ohm resistor, or you can use any resistor from 100 to 500 ohm. This is basically a current limiting resistor, a safety resistor. So you will connect the longer pin to one end of the 220 ohm resistor like this. Then the other end of the 220 ohm resistor will go to any available digital input output pin of your PIC. So I'm going to use a pin number D1 for this. That is the pin number 20, because this is available in my project. In this way, we have the sensor, the LCD and the LED available. Now guys, before we continue, let me introduce you to the hardware, then we will get to the programming. So guys, this is the hardware we have here. As you can see, this is the LCD, this is the LED I'm going to use, this is the PIC, and this is a PIC16F877A burner, and this is our sensor right here. And this is the gas valve. That's why I have moved the circuit here to the gas valve. Now whenever I will open this, it will send the gas, and then this sensor will read the data, and then this will display it on the LCD. So this is a simple hardware configuration. So let's get to our programming. So let me show you the hardware. I want to show you another thing. You can see that the LCD is connected using the wiring shown in the presentation, and this is our LED, as you can see here, and this is our gas sensor. Now the guys, this gas is here, and whenever I will turn it on, it will send the gas in the environment. Then the sensor will sense the environment, not the hose. So if this is even far away, like over there, still the gas will reach this place slowly. So that is the important thing. It doesn't matter that you don't have to install it right next to it. That is only for the demonstration purpose. You can install it anywhere in the room. The moment the gas hits it, it will know there is a gas, and the reading on the screen will change. So let me show you how it works. So guys, this is our mikroC for PIC. Let me zoom it in. I'm going to use a version 7.2.0. You can use a higher version as well if available. So first of all, click on File, New Project. This window pops up, New Project Wizard. Click on Next. Write the name of the project. LPG, CNG, Gas Detection System Tutorial Learning Microcontrollers. This is the name of the project I just wrote. PIC16F877A is the one I'm using, and 20 MHz is the crystal I'm using. Click on Next and finish. Now before doing anything else guys, first of all press Ctrl S to save your project. Save it. Now go to the right in the micro library expanded, system library expanded. Here you have these libraries. Select the libraries you are going to use in this project. We will need the ADC library because our sensor gives output in the ADC form. Then we have to convert the ADC value that might be stored in an integer or a float variable. We cannot display the integer or a float variable directly on the LCD. For that purpose, we will need to convert it to a string. So for that, we will need the conversion libraries as well. So conversion library will convert the integer into a string. Then we will need the LCD library for our LCD. Now expand this LCD library and go to the LCD I90 command, double click on it. This will lead you to this page. Here in the example you have these commands. Copy them till here. It's copied, go back. Now paste it above the void main like this. Now guys, as you can see that it says that for RS pin he had used the pin number B4 while we are using C0. For enable pin he is using B5 while we are using C1 like this. For the data pin 7 we are using C4, not B3. For data pin 6 we are using D3. For data pin 5 we are using D2, and for data pin 4 we are using C2. So let me recheck. RS C0, EN C1, D4 C2, D5 D2, D6 D3 and D4 C2. Okay, that's great. Okay, now for the pin direction do the same. For RS we have C0, just copy the above ones here. C0 for RS. For enable we have C1. For data pin 7 we have, for D7 we have C4. For D6 we have D3. For D5 we have D2. And for D4 we have C2. If you are using the different pins for the LCD, you only have to change this. Your rest of the programming will remain the same. So it depends upon the microcontroller you are using or the pins you have available. So that doesn't matter. All the thing you have to do is just change these parameters. So recheck C0, C1, C4, C0, C1, C4, D3, D2, C2, D3, D2, C2. Okay, that's fine. Now go back to the LCD I90 library here. Double click. And below these commands, you can see that after these dots, you have this LCD I90 command. You copy it like this and paste it above after the void main like this. Now guys, you have your LCD initialized. You don't have to write this stress C.F4, stress C.F1 equal to 10 manually. That has been done on auto by this library. Now your LCD is initialized, ready to be used. Give some initialization delay. 100 will do fine. Now guys, by default the LCD has a cursor and I don't like the cursor. I will remove the cursor. If you want to keep the cursor, you can keep it. For that purpose, go to this LCD CMD library, double click on it and copy this command in from the example LCD CMD LCD clear. You paste it here and remove everything in the bracket like this. Now go back to the same library. Here in the available LCD commands table, you have a command. You look for this turn off cursor command, this command, turn off cursor. Copy the command in the green, go back and paste it inside the bracket like this. Now give some initialization delay. This command will turn off the cursor. 10 will be enough. Now we will need some ADC pins. Our sensor is in the ADC output format, like we are using analog out. So we will need the ADC pin. For that purpose, go to the ADC library. Here you have this ADC I90. Double click on it. Double click on it. This appears, and in the example here you copy this command ADC I90 and you place it below it like this. And give some initialization delay for the ADC pins to initialize. This command will initialize all the ADC pin of your PIC microcontroller. So our ADC module is now initialized. Now the last thing is we have an LED at D.F1 as shown in the presentation equals to 0. This command is like in case of Arduino we write pin mode output. So it's in case of mikroC it's like D.F1 equal to 0 means it's an output pin. If there was a button here, we were to write 1. 1 means it's an input pin. Now we give it initial state. Initially the LED must be off. For D.F1 equals to 0. Give some initialization delay. LED is initialized and LED's initial state is off. Now we go to our forever loop. Write down while 1 starts here, ends here. Inside it, first of all, we will need a variable which will store the value coming from the sensor. So we take an integer int gas. This will store the value coming from the sensor. You copy it, paste it here, and write down gas equal to ADC underscore read value from which channel? Channel 0. Now this is the syntax of the command. Gas is the variable which will store the data, and this ADC read is a syntax, and this is the channel. I am using pin number A0, so I wrote 0. If I was using 1, then I was to write 1. So data will be read from the channel 0 because wire is connected there. Give some initialization delay. 20 will do fine. Now the next thing is we cannot display this gas value directly on the LCD. We will need to convert it to a string. For that purpose, go to the conversion library. And in the conversion library, you have int to string command, this command. Double click on it. It will open up like this. You copy this command from here. Now you see that this is the variable which will be converted to a string, integer. Now we will need another variable which will be store the converted value into a string. For that, go above void main, write char gas 1 and 5. So in Arduino you directly declare string gas 1, but in the case of mikroC you do not have a string variable directly. So what you do is that you take an array of char. An array of char is a string. This means it's a string having maximum of 6 characters. 0 to 5 means 6 characters. So we write gas 1 here, this string, this one. So whatever is in the gas, this integer will be converted into a string and will be stored in this gas 1. Give some initialization delay, 20 will do fine. Now the next thing is we need to display this on the LCD. Now for that purpose, go to the right in the LCD library, click on this LCD out command, double click and copy this command here. Now it's copied, go back, place it below the conversion library command. Now this is the row from where it should start writing, and this is the column. Start writing from the first row, first column, what it should write, whatever is in this gas 1. Now we also have an LED, but we cannot use the LED until we don't know what value, at what value the LED should turn on. For that purpose, first of all, we will need this for the purpose of calibration. So now what I do is that I give some initialization delays, so the value stays on screen for some time, like for 50 milliseconds, like this. Now I build this code and check for errors. The code is built, no error. I go to the PIC16 programming tool and I go to the file, select the file. So this is the file. I click on write. The new file is being written. Let me zoom out. Let it write the new file. Okay, the new file is written. Let me power up the PIC from this software, and let's get to the hardware and see what happens. Okay, let's get to the hardware. So guys, you can see that the value is being displayed on the screen. It is showing 128, 126 value. Sorry, that popped up. So as you can see that it is displaying 123 value when the gas is in the normal state. See, this valve is closed. I have not turned on the valve. Now I turn on the valve and see the value changes or not. So I am turning it on. So the valve is now turned on. Now see that right now it didn't change. The gas has not reached the sensor. See, it is changing now. You can see that the values are changing. It is going up. See that. Now I close the valve. So the valve is closed. Now the value starts going down to 25, 24. You can see that. So guys, you can see that the sensor is here and it is here. If it was far away, like this valve was over there, then the value was to change after a very long period of time, but it was to get affected. So it is not necessary you place it right next to it. It's fine if you install it anywhere in the room. Now we know that whenever it goes above 200, we can take any value, like I take 200, that if it is above 200, it means the gas is detected. So then this LED will turn on. Now we add this to the code. Now we note the calibrated value that it must be 200 in our case. So let's get to the programming again. So this is our mikroC for PIC. Let me zoom in. Now see that over here the gas, this value is taken here. So whenever we whenever we will apply conditions, we will use this value directly. So I write here, if gas is greater than 200, then it should turn on the LED, this LED, which is initially off. So initial state will be changed, it will become 1. Else condition is that if it is below 200, this LED will turn on. Now these few lines will do is that whenever the gas goes above 200, then it will turn on the LED as well, and when it is below 200, it will remain off. Then it will convert this to a string to be displayed on the LCD. Then the converted value will be displayed on the LCD as well. So let's build this code and see what happens. Okay, it's built without any errors. Let me recheck. Okay, it's built. Now I go to the mikroC for PIC16 programming tool. This I click on write. Okay, the new code is being written. Let us write the new code. Okay, the new code is written. Now we get to our hardware. Let's get to the hardware. So you can see that at this time the value is at 152 and LED is off. Now what I do is that I will turn on the valve so I can increase this value. So I am going to turn this on. So now the valve is on. So the valve is on now. The value will start increasing. See, it is increasing. Let it increase. See, when it goes above 200, the LED turns on. The value is above 200 and LED is on. As you can see, now I turn off the valve. Now the valve is off. You can see that valve is off and the gas is still in the air. Now you can see that the valve is off and the gas value is dropping. And once it's go below 200, LED has turned off. See that? Now with this analog right pin, you can take various values that when there is little gas, less gas, more gas, moderate gas. You can play with this code. It's a very nice project and very useful as well. See, the gas is still in the air. Gas is still in the air. It has not gone out. Now the gas has dropped. See. Now I again turn on the valve. Again the valve is on. You will see the value will start increasing. So the LED is on now. See that? I turn it off again. The LED will remain on. In case of other applications, you can replace the LED with a siren or with some sort of tripping relay or a valve which is connected to the gas pipeline that it will emergently turn off the gas supply. Now see that it is falling. Once it go below 200, see, it had turned off. See, because gas is in the air, it is still particles are moving here there. See, it is off now. Now I again do the same. Now watch from a distance. See, it's on. Now I turn it off. Now once the gas value falls below 200, it will auto turn off the LED. Now guys, once you are done with the calibration, you know that 200 is the value for you. Then you can even remove this LCD. You no longer need the LCD. You only need the tripping stuff like a siren or an LED, etc. So that's why I told in the presentation that this LCD is for the purpose of calibration. So once the calibration is done, you can remove the LCD. It is not necessary that you keep the LCD with the project if you don't need it. But for the calibration purpose, you will need an LCD. Now see, it's 204. It's falling. See, it's off. So guys, this is it. This is the project. I hope you guys learned something from it. And if you have any question or queries, you can ask it in the link in the descriptions, or you can simply comment me, or in the link in the description there is my email as well, and I will also provide you link to the other good codes like Introduction to PIC. And if you have any question, you can use the comment section. So thank you very much for your time and have a nice day.